Simplify each expression. Use absolute value symbols when necessary. Write all your answers without negative exponents. In this first expression, with 4 as our index, we can rewrite this with a fractional exponent, y to the 3/4. It's being divided by, and we can also write this one with a fractional exponent, y to the 1/6. Since our bases are the same, we would like to try and subtract our exponents, but in order to subtract fractions, you have to have a common denominator. That would be 12. So we can multiply the 6 by 2 and multiply the 4 by 3. That would give us y to the 9/12 is being divided by y to the 2/12. And then we subtract our exponents, and we end up with y to the 7/12. And that's a positive exponent, and that's pretty good. We don't need to change this back to a radical. If you'd like to, you can. Since this fraction doesn't reduce, we're done. Looking at this next expression, let's change everything back into fractional exponents. So that would be x to the 2/3 times x to the 4/5 divided by x to the, believe it or not, 3/2. That index, when it's invisible, is a 2. And so that's the denominator. Our base is the same everywhere, so we can just work with our exponents. This would be x to the 2/3 plus 4/5 subtract 3/2. Now, in order to make all of these fractions combine nicely, we need a common denominator. That common denominator is 30, so we need to multiply by 10 in our first fraction, by 6 in our second fraction, and by 15 in our third fraction. So that gives us x to the 20/30 plus 24/30 minus 45/30. So that gives us x to the negative 1/30. Now remember, you cannot leave negative exponents in your answer. So we need to write this as a final answer without a negative exponent, which means the negative exponent becomes a reciprocal, 1 over x to the 1/30.